Oh, okay. I just heard a message saying the meeting's being recorded. So I'm in Edmonton, Alberta in Canada, and right now we're just starting spring. There's still a little bit of snow on the ground. So let me just, and what I'm going to do is I'm going to talk a little bit about what we're doing at Athabasca and also what some other people are doing, more with the intention of starting a discussion, because I don't have all the context, and that's why I was so curious to ask you, Frank, about your institution. So I'm not 100% sure of what the context is, but I'll give you some of the perspectives I have with online teaching science online, and a lot of it too is because the context I come from, that it's longer term, you set up a course and then you're teaching it. I realize here that you're in the situation where this has kind of been thrown at you because of the whole COVID crisis. And as I had mentioned before, this is almost like trying to change a tire in a car while it's running down the highway. And so there's considerations in the short term, but also medium long term. So I'll try to cover off a few of those things, but I just ask you for your patience if I don't hit it right on the first time, but that's why we can have the discussion later. So I'm with Athabasca University, and we're an open university. And so we're 100% online and at a distance. And so that's kind of the context I come from. We have about 40,000 students, which is about a medium-sized university for Canada. And they're all over the place. So we actually don't have them here. And the picture I have up at the moment is our main office in the town of Athabasca, but we have offices in multiple cities. And as I said, we're mostly online. And the town in Athabasca, or the main office, is in the middle of a boreal forest. And so we get a lot of wildlife up there. And you know, moose and deer and raccoons and all sorts of things. And we even get creatures like this, black bears, that come around and visit. And so usually about 2 or 3 times a year, there's an email that goes out to all the staff to be careful, because there's a bear that's wandering around. And sometimes they're very curious. They'll come and they'll look in the windows and so on. So I tell people, because we're online and doing things at a distance, if you come to Athabasca in the parking lot, you're more likely to meet a bear than a student. And so, but I don't know which one is more dangerous. So, so a lot of what I'm drawing on, and Frank mentioned the book that I have, and it's with Stylus, and it's an edited book. So it really is, there's about 30 authors that kind of from around the world and in different disciplines in science. So earth sciences, physics, chemistry, biology, and so on, who have contributed to this and give their perspective, and they're from around the world. So it can give you a lot of interesting ideas of how to approach this, because there's really no one right way. And so, I'm going to be drawing, you know, not only what we're doing at Athabasca, but on the experience of some of my co-authors. So as I mentioned before, a lot of this is context, and so a lot of people look at online and distance as kind of the future, but it's you have to be careful, because as Yogi Berra said, the future is not what it used to be. We kind of have to think very carefully what we want our students to be doing. And so as a I guess, a foundational piece, I've looked at, and I think people should really look at skills for the 21st century, because they have changed. And so I sent Frank some handouts, and so some of this is in detail. So if you are interested in some of this, Frank, if you wouldn't mind sharing with other people who are interested some of the handouts, and you can look at some of the details on this. But essentially, the skills are grouped into 3 sections, and Group A is not surprising. It's the same as it always used to be. There's just general education skills like problem solving, critical thinking, communications, those sorts of things. Group C is not surprising either. These are profession-specific skills, so they're disciplinary skills. So if you were a chemist, how would you use, a certain analytical instrument? How would you go about doing a lab? If you were an engineer, it might be professional ethics and those sorts of things. But it's Group B that I want to draw your attention to, and these are emerging skills that are coming out in the 21st century. And so I'll just note them here, and you can read them for yourself. And so these are the sorts of skills that are going to become more important as we go into the future. And what I find really interesting about this is, if you look at them, it's only really the last two bullets that really are keyed into, technology. A lot of this is not necessarily technology. And so this is one of the messages I want to get across is, even though we can do a lot with technology to get online and solve short-term problems and so on, it's not everything. And so as science educators, we need to think about that and not necessarily be influenced always by the technology. And so I'll leave that with you to think about. What I wanted to point out now is and Frank mentioned this earlier, is that sometimes it's really hard, and I think our colleagues at the rest of the university don't always realize this, but teaching science has specific challenges to it, and doing it online, doing it correctly online, is even more important, has more challenges. And I just wanted to point out a few to you. One of the things that I think as scientists we kind of take for granted, that we have to deal with a lot of concepts and skills and ideas in science that build on each other. And that necessarily is not true in other disciplines like humanities and social sciences. And so we kind of take this for granted, but it really does make our work more challenging. So a lot of times students have to have, say, for example, mathematics before they do physics and those sorts of things. We have to, before you can do advanced microbiology, you have to do introductory microbiology. So it may seem as a kind of an obvious thing for you, but for other people, it's not. The whole idea of going online is almost a paradigm shift for a lot of academics. So this is kind of a longer term thing if you're going into doing more things online and designing courses and so on, that you try to move away from what I call the Lone Ranger sort of approach and more of a team approach. And so we're quite lucky at Athabasca University. When we develop a course, I get to work with learning designers and editors, graphical designers, IT people, and so on. And we work as a team to put together a course. And so this is kind of the way of the future in doing this, but it's difficult for some academics because many of us have been quite used to just doing a lecture in front of the students and being self-contained, and we do everything ourselves, right? And so we look after everything ourselves. And then to work in a team can sometimes feel unusual when it comes to teaching and learning. The literature around teaching online in the sciences is, I have found over the years, to be quite scattered. And so having things kind of pulled together or in the context of science, it's difficult to find. So you really do have to look hard. It's getting better though. A lot of us come into teaching, but we're quite often, I don't know what it is like in Ecuador, but in the US and Canada and most of Europe, we are content experts, but we're not necessarily formally trained as teachers or have the technology background. And so when we come to a university as a, you know, a young scholar, as an academic, we have to quite often come up to speed ourselves on being a good teacher or learning to use technology. So that's a problem, and it's not just limited to science. I see that across all disciplines. And finally, the biggest thing, and Frank mentioned this at the beginning, is he said a lot of our courses have labs, and what do we do? That's probably the biggest question I always get, is the practical components, the labs, the field work. If you're in engineering, design projects, how do you do that? And so most of my presentation, I'll be kind of focused a little bit more on the labs, because a good lab is at the heart of many science courses, science programs, but it's often the most difficult thing to deliver and do correctly at a distance. And so this slide basically lists a few reasons of why we might do a lab, and you can add to that list. There are many, many more reasons for doing labs and why we have them. But what I wanted to point out here was, and this is something that I came across when I was a young assistant professor starting off. I, like many others, have had like a residential experience where I was doing my science face-to-face, and all of a sudden I'm at a university, this open university, and they're doing everything online. And one of the first things I needed to do with my courses was to ask, you know, does the course need a lab? You know, why am I doing the lab? And if it did, and the answer could be yes, definitely we need the lab. Why is it that you need the lab? What do you want to get out of the lab? And so this, again, is kind of a medium to long-term approach. I think probably most of you are thinking right now, I have a lab, I just need to get the students into the lab somehow and do something that's either the lab or something that's equivalent. But as you're thinking about going on into the future, this is an important question, is what do you want to get out of it? Because a lot of us, you know, when you inherit a course that already has a lab, not many of us kind of think to ask the question, well, why is it that we're doing the lab? So I would encourage you to kind of take that step. This slide here, I just wanted to kind of, this is the way I look at all the different, or try to do a taxonomy of all the different ways that one might try to do laboratory work at a distance or remotely, and how to accommodate that for online. So I have various groups here, and I just want to go through this. Hello? Sorry, was that a question? No.
No, the microphone was on, just.
Oh, okay. So face-to-face. So this is kind of a gold standard, and most traditional universities will have this, and it's very well understood. But when you're using it in conjunction with online, quite often we do variations on this. I've seen, for example, regional laboratories. So we set up smaller laboratories closer to where the student is that they can come and visit. I've seen where perhaps a teaching assistant might be looking after students in the lab, but then there's a video connection to the professor. So you might have that kind of blended mode. The way we do it is we have concentrated sessions. So we have supervised labs, but instead of doing a 3-hour lab once a week, the students come in for a 3 to 4 day visit, and they do concentrated labs. And the labs don't have to be 3 hours long. They can be multiple days, or they can be as short as an hour, and the students work their way through it. Now, this is not going to help you in the short term, because all of this supposes that you're face-to-face, and that's not going to work with COVID. But just keep it in your back pocket as, you know, for later on, if you're doing things, trying to reach students that are maybe further away, this is one option. Another that I'm a chemist, and we haven't used this as much, but some of my other colleagues that use have field components have started experimenting with this. So mobile devices are very powerful now, and if you combine that with GPS, you can do a lot of situated learning. So you have the various apps that can identify uh, things out in the field. You can have apps that let you know where you are, and then they will kind of guide you through field work. So if there, for example, special geological features that you want students to look at, or so on. So there's multiple things that you can do here with mobile devices, including taking notes and also collaborating and communicating with other people too. So we've started experimenting with these sorts of things, and because of the popularity of things like citizen science, where they actually get public involved in doing certain measurements, there are many more of these apps available out there. So this might be one way of doing field work, or getting students to look at things where they are remotely. And so you might be able to do a few things like that by looking at mobile apps. Related to this, a little bit, I guess, you probably heard of a lot of virtual labs, and by virtual labs, I mean specifically computer simulations, where you can either, some of these can be quite fancy, or they can be stripped down, like the example that you see here. They can be online or standalone. So you actually get the students to go through and do these virtual labs. And of course, in a virtual lab, it's a slice of reality. And one thing I wanted to point out to you, because when people get into this, they seem to assume that the better the graphical interaction, the more real it looks, the better the learning experience is. And that's not necessarily true. Especially for undergraduate students that are more novice, it's almost an advantage if you have like a smaller piece of reality to get the students focused on a specific thing, rather than having a really complex and rich virtual experience. And so something like you see here, which looks very cartoonish, is a good vehicle for getting students to learn certain things. Later on, I'm going to talk about combining various labs, but one of the things I wanted to point out is that a very common thing to do is use a virtual lab, a simulation, and then a real lab. And people used to think about it as if they were training a airline pilot, where they would do the virtual lab first and then do the real lab. And the students would, have some background and they would do better. People have started experimenting with that, and have also found it goes the other way around too, where some groups have seen you start off with a real lab, and then later on you do some exercises with a virtual lab, and learning also occurs. And so somehow what we learn in a virtual lab and what we learn in a real lab, they can reinforce each other, but they're not quite the same. So the old argument of like, which is better, a simulation or a real lab, now we're seeing more that the combination of the two are stronger than either one on its own. I just wanted to kind of mention that and throw it out there. Related to laboratory simulations is something that we've started working on, and that's remote control labs. So you can do this in various disciplines. We were fortunate in chemistry, a lot of analytical instruments, they're very sophisticated instruments, are already controlled by computer. And so you can get software, and it's not that much harder to actually come in through the internet and control an analytical instrument. And when you combine that with an auto sampler, students can come in and work up a sample on their own time. And so unlike what I was showing you before, a virtual or a simulation, here you're actually working on real samples in real time and getting real results. And the nice thing about that is sometimes things don't work out exactly and you get non-ideal results. And so students can learn from that. And so there are various remote labs that are out there, and there are various consortia. So another option might be if you can find something in your discipline area that there's a remote experiment that's already out there, or someone you can collaborate with that's hosting an experiment that you can send your students to. Sometimes that will work out quite nicely as well. And then one thing we've had a lot of success with is home study kits. So if the students can't come into the lab, in some cases you can send the lab to the students. We can't do this with all labs because of safety and other reasons, but with some of the labs we can do this. And so here you see one of our students on a skidoo in northern Newfoundland and Labrador with one of our chemistry kits. And so we can send a general chemistry kit to these students and they can do the experiments on their own at home. We've done it in other areas too. We have home kits in biology, and this is a physics one. And so these are quite simple. We used to, with the physics, these are mostly just sensors that you can hook up either to a graphing calculator, or you can just hook it up to a laptop. And it's absolutely amazing. I remember when I was going through physics, we'd have these carts that would go down ramps pulling a ticker tape, and then I would spend hours, measuring the distance between dots and then graphing that. Well, now a student can bounce a basketball and with a motion sensor can get all the data and have it graphed within seconds. And so they can focus on the science rather than having to do all the manipulations that are behind that. And so we've had a lot of success with these lab kits because students would rather do a lab kit than come into a physical lab. Here's our chemistry ones. The kit that we use is on the right-hand side. It's the bigger one. We used to just do half the labs with a kit. And I show the picture on the left here, and I had to show this. For the younger people, the white box that you see on the road there is a VHS, so that you probably won't recognize that. That's old technology. That'll kind of give you a sense of how old this is. But I told our media person I wanted to show this is because this is the first lab that we had that was on the road. So I said, I want to show, we have the lab on the road. And he took me literally and actually took a photo of the lab kit on the road. So I just had to show that. So those are I guess the different types of delivery strategies I've seen. And what I would encourage is not to think of this as like either or, like that there's one way of doing it. And in fact, I would also encourage to blend and combine various things. And I already talked about how a very common combination is virtual and face-to-face, that you would do a simulation and then go into a real lab. We've done ones where I had a organic chemistry experiment where we were dehydrating an alcohol to form alkenes. And so we get a series of alkenes, and the students would separate it with gas chromatograph. And so the students would be in a face-to-face lab, and they would synthesize their sample, their compound, and then they would leave it, and we would give them a sample number, and then they would go home, and they were intending to analyze it through remote control, so actually analyze their own sample, but to learn how to operate the instrument and learn more about the chemistry behind it, they would do computer simulations. And so they would learn how to use the instrument. And so we combined 3 of those areas. And so you can mix and match and do these things and not necessarily just get out of the idea that you have to do one or the other. Combinations work quite well. So that's on the lab side. And I wanted to kind of, as we're getting to finishing part of this, presentation, is just to quickly talk about more the theoretical part as well. So we have that. And what I've done is I've just listed the top 10 best practices that I've found and the people who contributed to that book I mentioned have found. And you'll look at this and you'll go, oh, well, this is quite obvious. But I thought I'd bring it out to you anyways, just so you have it in front of you. This is what lots of people have been doing over the years and have found works well in multiple disciplines in science. So, and of course, good teaching is good teaching, whether you do it online or do it in the classroom or remotely or whatever. So when you're trying to incorporate technology and communication technology is to engage the learner early and often, just like you would in the classroom. Focus on the concepts and the science itself rather than the technology. So as I mentioned before, don't chase after the technology. Think about what you want the students to learn, and then the technology should be serving you in meeting that goal. The team approach, I've mentioned this already, and I think that and it's one thing that I said people kind of hesitate about, and I'm always surprised because in the sciences, on the research side, scientists are very comfortable collaborating and working together, and so I'd like to encourage that as well on the teaching side. Open educational resources, we haven't mentioned this before, but one other characteristic I find with my colleagues is that everybody wants to develop their own sort of, their own thing or put their mark on things. But open educational resources, there's a lot of material that's out there for free that you can use or adapt. And I would strongly encourage you to do that. The good news is it's free and it's out there. The bad news, of course, is along with a lot of good things, there's a lot of stuff that you have to kind of wade through and that is mediocre or not so good. So you have to look at that and see what is useful for your course or for your particular situation. But it's well worth a look. One of the big problems, especially in a situation where someone is coming right from, let's say, classroom-based and doing online, they get very enthusiastic and want to put a lot of things in, or they get enthusiastic about technology. That's a very common problem, is the cognitive overload for students. It's so much easier in an online course to put too much material in. And so you have to be very cognizant of that you don't overload your students with the technology or with extra content, because it's just easier for you to do. When you're in a classroom or a lecture theater, you're kind of slowed down a little bit because you can only cover so much material when you're talking to students. But when you're just kind of giving them things, it's very, very easy to overload. Another obvious point is to use technology that you're comfortable with. You need to be able to understand or have someone help you with it wherever possible. Select, and this is kind of medium to long term, select those technologies that have proven to work and don't necessarily, it's very difficult to, when you are doing the newest and latest thing, quite often you can run into trouble unless you have the proper support. And speaking of support, training for both students and faculty is really important, because there's been this mythology that, especially for students, because they're younger than us, just because they can do Instagram and you know, create TikTok videos or whatever, that they must know everything about technology, but that's not the case. You need to have the supports in place to help students and the faculty. Exploiting technology where it will have the greatest effect. One of the things that I think is overlooked quite a bit is automation. If you can use technology to automate things like drills and other things, so you can spend your time doing the higher touch things. So use technology not necessarily for the flash value, but for kind of the repetitive heavy lifting, to have the technology do that while you spend time with students doing the more complex and more sophisticated questions and things. And then finally, students have always surprised me. When you're doing a course, when you're dealing with technology, they'll always use it in ways that you hadn't thought of. And that's always an opportunity for us to kind of incorporate ideas from our students. So we also learn from our students. So takeaways on this, think about skills in the longer term and for the future. Ask yourself what you really want to get out of the laboratories that you're doing. Consider the modes that I showed you of delivering labs. Consider blending them, mixing them. Don't think there's one solution for every discipline, or even for your own discipline or particular course. There could be more than one. Think about those best practices and using appropriate technology, not necessarily for flash, but what are you trying to get out of it? Because quite often what students want and what they need are two different things. And as we've always done as science educators, quite often we're a bit further down the road than the students. And so we have to sometimes look out for them and provide them not necessarily what they think is great, but what will be best for them in the longer run. And think about, it's not just technology. Technology can help if it's in the right hands, but a lot of this is more than technology. And then as scientists, I would also plead that try to pick things that's evidence-based. So things that will actually show increased learning, or if it's engagement that you want. So target those things and think about what you're trying to get out of it. And so I'll leave it there, and we can have a discussion, and I'll see if I can find the chat box. But thank you very much for your attention, and I guess we'll open it up for discussion.
Thank you so much again, Dietmar. Yes, there will be some questions here. I don't know if you can see the chat now, or if you want to read the.
No, I'm looking for the chat. So
at the bottom of your screen. I can read the questions for you, Dietmar, if it helps.
Okay, while I'm looking.
Oh, you have?
No, hang on a minute. No, it was at the top of the screen for me. Okay.
Ah, yeah.
All right. Okay. Okay, now there's a note from you to Abby, so I'm just going down. Good afternoon, everyone's saying hi. I'm just scrolling through.
Yeah.
Hi, hello, hello. Oh, okay. So I've got a question from Anna. She asks about collaborating between students. And do you have any experience in providing accommodations to students with different needs and backgrounds? So for most of our undergraduate courses well, one of the things I forgot to mention in the presentation was when, as an open university, our undergraduate courses, we don't have terms or semesters. So we have continuous enrollment. So students are enrolling all the time. So any particular course we would have, I have students that are just starting it, and I have students that are finishing it, and everywhere in between. So this is one of the challenges we have. We have a lot of, because these courses that we have, they're mostly asynchronous, self-paced courses. So the students are interacting with the content quite a bit. And there's a little bit of teacher student interaction, and there's very little student-student interaction. And that's just in the undergraduate programs. Things change in some of our graduate programs where some of the assignments are like group assignments, and students then have to work together, and they correspond with each other with email or Zoom within the course, or sometimes within our learning management system, which is Moodle, doing conferencing and that. So it depends on the course. There's a possibility of doing collaborative work, but you have to, especially with undergraduates, you have to set it up for them and put them in groups. It doesn't happen naturally. And so this is something that would have to be part of an assignment or so on. And do we have experience providing accommodations to students with different needs? We have, now, I'm wondering if you, Anna, if you mean disabilities. Is this what we're talking about for accommodations?
Yes, that's what I meant.
Okay.
Sorry for jumping in. Yeah.
Yeah, no, that's perfect. Like, I just needed that for context. Yes, we have a disabilities office, and we get quite a few students that come to us because we're online and at a distance. So we get a larger proportion of students self-identifying with disabilities, and most of those are learning disabilities, not necessarily physical disabilities, because of the way we do our courses. And so for a lot of them, it's easier to do if they're doing it online. There's certain advantages to doing that rather than being in a classroom. And so just the nature of doing things online helps our students. Now, having said that, sometimes we have to do special things. So some common accommodations might be on examinations, where we have to give extra time, or have examinations in certain formats for students. Another common accommodation is with our online materials, we have to make sure that we incorporate a certain amount of universal design so that students, so if we have like a blind student, there's certain readers that will go through online materials. But if you put too many things in there that would block most standard readers, it's not accessible anymore. So we have to build that into our design. So those sorts of things, we try to do that. And there are, communities of practice that discuss these sorts of accommodations that you can make. So if you have a particular problem and you can't think of an answer right away, there are communities that you can go to ask questions and do that sort of thing. But we're quite fortunate that we have staff that specialize on this. And so when I mentioned when we design a course, we don't necessarily have access to students with disabilities person on the team, but if we ever had any questions about universal design that we wanted to use, we have those people available to help us. I hope that answers that, Anna.
It does. Thank you.
Oh, thoughts on assessment? So I'm not getting the context of the question here. It's just like, are assessments good things, or what do you mean by that?
No, I think the question is from Israel. Israel, I don't know if you're online.
Yeah. Hi, everybody. Well, I was asking this about exams. We are quite used to the idea of having midterms and final examinations, so it's a little bit awkward for us to do these evaluations in this way. So I was talking about how do you evaluate your students? How do you assess that they are actually getting what we try them to know?
Okay, so most science undergraduate courses that we have will have 1 or 2 midterms and then a final exam. Sometimes they will have also assignments which are assessed. And then quite often, if there's a laboratory component, there's laboratory reports that are assessed. And some of those courses would also have a very short lab exam. And they might also be assessed actually when they, if you know, like in a face-to-face lab, what their participation is like and so on. But with the exams, the midterms and the finals, our standard has been mostly to have in-person exams, paper exams at invigilation centers. And these centers can be across Canada and around the world. So normally it would be at another university or college somewhere else that we send them the exam, and then they do the invigilation for us. Now, this has been a real problem because of COVID. We can't have students coming together anymore, even though they're remote. And so there are various solutions that we've had to this, that we've had to kind of to accommodate this. One has been doing exams online. And the problem there is most of the software that you get, they're very good at multiple choice, but as soon as you start getting more complex questions, it becomes more difficult. And there's more effort into building exams like that. So that assessment is kind of difficult to do. Some of my colleagues are doing now jumping to, especially if their classes are smaller, jumping to oral exams. So they will Skype someone and just, and you can do this quite quickly. You know how much a student knows the course or not by talking to them. One thing that I've done, and a few of us have done, is I've gone from, because right now I'm teaching organic chemistry, and I'm also teaching environmental chemistry, and both of those require doing calculations, using formulas, drawing structures, and so on. And so a lot of software doesn't work very well with that. And so what I've done is kind of abandoned the very simple sort of exams, and I've done more of an open book exam, but I've had to put it at a higher cognitive level. So it looks more like an assignment. So it's more problem solving, analysis, evaluation, that sort of thing, rather than simple recall. So I build a lot of things into the questions, which was quite a mind change for me to kind of make a different type of examination to accommodate this. We also have, a few of us have been fortunate enough to have online exams already. But like I said, the limitation there is that it works well for multiple choice, but as soon as you start trying to do something a little bit more, it becomes more complex, but it's doable. I hope that answers your question, Israeli.
Yes, thank you very much.
Let's see, what else do we have here online? How long will it take to develop a virtual lab based on your experience? And this is Frederico. It really depends on what you want to put into it. you know, to design a good lab, I would say, and if you had the right team and everything, it would take a year to do it. And this is why I've strongly suggested to go out and either look at commercial materials, or I would strongly suggest the open educational route if you can find applications or things that are already out there that you can either use off the shelf or easily adapt, rather than, you know, especially for any short-term solutions that you want to have. But in the longer term, if you are looking at, you know, once COVID is gone and that, do you want to have some labs or components of some labs that are virtual? I would encourage you to go through and design that. Start off with the learning outcomes and go from there. But it's not a trivial thing, and I would caution you to jump into it too quickly. Put in your agenda a visit to Ecuador for a seminary, please. Okay. On my bucket list then. I've never been to South America. I should go. Let's see. Course material. Okay, I imagine that change depending on course material. Language classes would have more professor-student interaction. And information-based courses like physics or biology would have more interaction with the content. Yeah, that's absolutely true. So a lot of, and am I talking mostly to scientists, or do we have a broader sort of audience, Frank?
Actually, I am not 100% sure, because it seems that many people from other universities also joined the presentation.
Oh, okay.
But I would say probably, yeah, it's mostly scientists.
Okay. Yeah.
There are some.
You're cutting in and out. I can't hear.
That there are some English teachers too connected.
Oh, okay. So, so yeah, I know from my colleagues in humanities and social sciences that features on learning management systems like conferencing and having discussions and setting up video seminars, there's a lot more value to it than you might find within science, because that's very true that you are connected more to the content. So having a discussion on, you know, what you think about a particular molecule might not be that advantageous. So you have to really target what you want to do. On the other hand, one of the things I've seen that works really well for, because I've been approached by others who are going through this in the middle of term, trying to flip over quickly into online mode, and to kind of dovetail that a bit better, both for faculty and for the students, is if you can find online material that the students can read, but then offer a regular, let's say once a week, a class where you can discuss things. So they're mostly interacting with the content online, and then it's almost like a flipped classroom. So you're doing it all online, and you discuss the kind of higher order things once you get together, or you know, work out problems together, rather than covering material from the ground up at you know, like face-to-face, well, online face-to-face sessions. Can you send us your email? Yep. Oh, you've got it there already. Thanks, Frank. Meeting important. Do you have project-oriented courses? That's something I often see with programming courses. And that's from Samuel. Yes, we do have project-oriented courses. They tend to be more senior undergraduate So the assumption is that once you've had some foundational courses, you can then have, like a capstone course or something like that, that kind of brings together some of that foundational stuff. So for computing and engineering, most of those projects tend to be design oriented. We also have within sciences, because you have to imagine our students are everywhere, we have a unique project course that we offer where we have a three-way agreement between the student, a professor, and then we usually try to find a local supervisor somewhere. And this could be at another university, it could be in a government lab, it could be in industry, and get them to actually supervise the students there. But then you pull together between the three a project and how that project will be assessed, and you do a learning contract. And we found this to be quite successful because we've had students doing projects all over the place. And it's easier than it sounds for our students, because many of our students are more mature students and they're already out there working. And so quite often this will mean, if they're working in a government lab, that they will be assigned a specific project to do under supervision for credit in a project course. So we do those sorts of things. But it varies. I mean, there could be mathematics project where students just work directly with the professor, because you don't need to have any physical sort of presence or to be able to collect data that way. So so there's different ways of doing project courses, and we've incorporated that into senior undergraduate courses, and obviously for our graduate courses. And so they can be project oriented or thesis based, or they can go on from there. Can you suggest some good apps to teach science, specifically biology? Yeah, if you would send me an email, I can give you a list of some websites that I have, and I can also put you into contact with like biologists, so who would have a better feel for that, especially if you have like a particular, is it general biology or microbiology or physiology, or if you have it narrowed down a little bit more, that would help with picking a person. And then you can, I'll get you set up with that. So if you just email me and just remind me about that question, I think that's probably the easiest way to handle it. Yeah, and someone asked me, I think it was Gloria, can you share your slides? Yes, I've sent Frank the slides, so you're welcome to look at them and use them. I'm not 100% sure. I don't own all the images on the presentation. So some of them, I'm hoping they're not too much copyrighted, but I think it's fair use, because most of us will probably just use it for educational purposes anyway. So.
Yeah, I would like everybody to, maybe if you can send me your email, we can share the video with you and the documents that Dietmar said. Of course, the video cannot be shared with other people. But we record the video, Dietmar, for some of our students or professors who are in class right now and cannot attend this webinar and would like to watch it later when they get home. That's the reason.
Okay. All right. Have I missed any questions? Are there, because I kind of read through the list quickly, so.
Any other questions? I think we are on time. They have your email, and I'm sure we will be in touch, I hope, in the near future again. Thank you so much, Dietmar, again, to present. I think at least I learned a lot, and based on all the questions, I think clearly it was really helpful. Really interesting. Great advices. Thank you so much again, Dietmar, for accepting this webinar.
Okay, it was a pleasure. So hopefully one day I'll meet some of you in person.
We are waiting for you here. Thank you so much.
Okay, take care.
Bye-bye.